Hello friends, my name is Keval Sredia. I am studying in VVP Engineering College in 5th sem. Today's my topic is the MOS system under the external bias. So first of all, module the MOS system under the external bias. The MOS system under the external bias. Inside a cross-sectional view, the energy band diagram of MOS structure. This is the VG less than greater than 0 small. This is the VB equals to 0 then ground. This is the depletion region. This oxide layer, oxide, then EOX. This is P-type substrate, silicon substrate. P-type P-type silicon substrate. So after that, this is the cross-sectional view energy band diagram of the MOS structure operating in depletion mode under small gate bias. So this equation dq equal to minus q charge dot na dot dx. So this equation number 1. After that, the charge in surface the charge in surface potential require to displace this charge sheet is called dq by a distance xd away from the surface can be found by using the position equation. Using the position equation. Like that, d phi s equal to minus x dq by epsilon silicon substrate. So d phi s, also known as x equals to q nax dq. So dq is equal to q na dx. Put equation minus x is minus minus plus. So x q na dx by epsilon silicon. After that, both side integration d phi s equals to integration q na x by epsilon si silicon dx. After this integrates phi f to phi s and 0 to xd distance. So phi s minus phi f equals to Q is Na x integration x d square by 2 and epsilon si as it is x d square. So x d square equal to 2 epsilon silicon phi s minus phi f divided by q and a. So square cancel, then under root. Is equation number 2. After the depletion region, charge density q equal to minus q and a xd minus under root q and a epsilon si phi s minus phi f. This equation is charge equation called charge. Then equation number 3. After that, equation number 2 and 3, put phi s equals to minus phi f. So xd is equal to under root 2 epsilon si 2 phi f inside mod divided by q and a. And equation 3 put in phi s equals to minus phi f, phi s equals to minus phi f. So q equal to minus under root 2q and a epsilon si minus 2 phi f. The MOS figure is like that. N plus impurity. This is the source and this is the drain. VB body voltage equals to 0, then ground. VB equals to 0, then VG S less than VT 0. VT 0, then VB equals to 0, then VT equals to 0. VT equals to 0 equal that VB equals to 0, then VB any voltage, but at that time this VB equals to ground, so VT 0, VGS greater than VT 0, get source is ground, so Vs equals to 0, drain is also ground, VDS equals to 0, then depletion region. This is the oxide layer. oxide. This channel bandwidth, channel, only channel. Depletion region. This substrate is p-type silicon substrate. This channel is n-type. So after that, QB equals to minus 2 under root in Q and A epsilon Si minus 2 phi F plus VSB. VSB is nothing but which is the ground potential, means reference. Then the depletion region charge density can be expressed as a function of the source to substrate voltage. Source to substrate voltage is VSB. The gate oxide capacitance. The gate oxide capacitance per unit area. COX. COX equation is epsilon OX by TOX. VB equals to 0, then VT0 equation is phi GC minus 2 phi F minus QB0 divided by COX minus QOX divided by COX. Then generalized threshold voltage express. Generalized threshold voltage express expression. So at that time VB equals to some voltage, VT equals to phi GC minus 2 phi F minus QB COX minus QOX divided by COX. So VT equals to QGC minus 2 phi F minus QB0 divided by COX minus QOX divided by COX minus QB minus QB0 divided by COX. So VT equation is VT equals to VT0 minus QB minus QB0 divided by COX. VT0 equals to phi GCS phi GCS minus 2 phi F minus QB0, then minus divided by COX minus QOX divided by COX. This equation is called VT0. So QB minus QB0 divided by COX as well as, so VT final equation is VT equals to VT0 divided by QB minus QB0 divided by COX. After that, QB minus QBO equals to QB minus QBO divided by COX equals to the equation is minus under root 2Q Na epsilon Si divided by COX into under root minus 2 phi f plus VSB mod is over minus under root 2 phi f. Put in equation, so Vt equals to Vt0 plus minus this called as known as gamma. So gamma under root minus 2 phi f plus VSB minus under root 2 phi f, where gamma equal to under root 2Q Na epsilon s silicon divided by COX. So Vt finalized equation is Vt equals to Vt0 plus gamma under root mod minus 2 phi f plus VSB minus under root mod 2 phi f. Mod is over. So MOSFET inside a 2 MOS, CMOS inside NMOS and NMOS and CMOS. Two types of MOSFET. CMOS inside a two part NMOS and PMOS. So Fermi energy phi f. NMOS inside a negative, PMOS inside a positive Fermi potential. After that, depletion region charge density QB0 and QB, QBO and QB. NMOS inside a negative and PMOS inside positive. Substrate bias coefficient gamma. NMOS inside positive, then PMOS inside negative. Substrate bias voltage VSB. NMOS inside positive and PMOS inside a negative. Thank you. Bye bye. Have a nice day.